Hi, this is lesson number 2. We're still going to be dividing polynomials, but this time we're going to be using a long division method. So the long division method is a little bit longer, probably not everybody's favorite method. What I'm going to do is I'm going to set this first example up like I would a long division problem from probably the first time you ever learned how to do long division. I'm going to put the divisor on the outside, make a division bar, and on the inside I'm going to put what I'm dividing into. What's really driving everything is going to be putting the x into each of the terms here. For instance, if I look at x and I ask myself, what do I have to multiply x by to get x squared, then I would put an x up here, right? X times x is x squared. I also have to multiply this by the second part, so x times 2 is 2x. And I'm going to go ahead and leave it at that. Now, what I'm going to do is I'm going to actually subtract this whole piece. So I have to put a set of parentheses around it, because when I'm subtracting the whole piece, that means I'm truly subtracting the whole piece, and I have to distribute my negative symbol. Essentially, what that looks like is negative x squared minus 2x. X squared minus x squared cancels each other out, right? Negative 3x minus 2x, because I had to distribute this over here, is negative 5x. And I also have the negative 10 that I'm bringing down. So now I need to focus on this part down here, and what I need to multiply x by to get negative 5x. X times negative 5 would give me negative 5x. And I'm going to take both of these terms and multiply them by negative 5 and bring it down. So negative 5 times x is negative 5. Negative 5 times 2 is negative 10. Remember, though, we have put the set of parentheses and the negative on the outside because we're subtracting this entire binomial. So negative times a negative is positive. So essentially down here I have I'm combining it with a positive 5x and a positive 10. Negative 5x combined with a positive 5x cancels out. Negative 10 combined with a positive 10 cancels out. There's no remainder. And so the answer to this is x minus 5, which is what I got from up here. We would have to keep doing this a few times in order to make sure that you understand, because this is a little bit confusing. Okay, so let's look at the next example. I have x minus 2, that's going to be on the outside of my divisor bar. Make my bar x cubed minus 4x squared plus 2x plus 5. Every single time, this is what is driving my whole division problem. I have to ask myself, what do I multiply x by to get x cubed? That would be x squared. So what I have to do is I have to multiply both of these terms by x squared and write it below. X times x squared is x cubed. X squared times negative 2 is negative 2x squared. I'm going to subtract this entire polynomial. That will give me x cubed minus x cubed, which cancels those out. Then I have negative 4x squared minus negative 2x squared. That means that I'm actually combining negative 4x with a positive 2x squared. So I have negative 2x squared as my result. Negative 4 plus 2 is negative 2. And then I'm going to bring down these last two terms. And now I get to focus again on this term for what I need to put on the top. So I ask myself, what do I multiply x by to get negative 2x squared? So if I multiply x by negative 2x, negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. I'm going to subtract this from what is above. The first gets canceled. My negative 4x is combined with a positive 2x. and I pull my plus 5 down. Remember, every single time I have to distribute this negative. I have to figure out, what do I need to multiply x by to get negative 2x, and that is going to be negative 2. So x times negative 2 is negative 2x, and negative 2 times negative 2 is positive 4. Remember that I have to subtract this. These cancel. 5 minus 4 is 1. So I have a remainder. The remainder is going to be 1 over my original divisor, and this is my answer right here. One thing that's really important to point out to you is this. If you end up having a problem, for instance, x to the 5th minus 1, that's going to be what I'm dividing into. Remember that you're going to have to put a place for every single step down exponent. I have to be able to account for x to the 4th, x to the 3rd, x squared, and x all the way down until I get to my constant. So that's really, really important. This one right here looks like it would be super easy, but then when you put all these in here, you're like, wow, that's a lot of stuff. So let's try this one here. Notice that there's a jump in exponents here. The x to the 5th is not there. And then I have x to the 3rd and x squared that are also not present, so I'm going to have to account for them by putting a 0 placeholder. So I'll show you what that looks like. Notice this is an x cubed term. When we were doing synthetic division, this couldn't be an x cubed. So that's the one thing about long division that's necessary to be able to know how to do it. X to the 6th plus 0x to the 5th plus 2x to the 4th plus 0x to the 3rd plus 0x to the 2nd plus 6x minus 9. Way longer than we thought it would be. I'm going to write up here what I need to multiply x cubed by to get x to the 6th, and that would be x cubed. Remember, if you multiply powers of the same base, you add the exponents. So down here, I'm going to say x cubed times x cubed is x to the 6th, and x cubed times 3 is 3x cubed. I'm actually going to put that down here. Actually, no, I'll put it right here. It's all good in the neighborhood. I'm just going to erase that last piece. Okay. Now I'm going to put the subtraction symbol, my set of parentheses. This cancels out x to the 6th. Notice that I still have 0x to the 5th. I still have 2x to the 4th. And I will now have 3x cubed. Because I'm adding that from what I had before. I'm bringing everything down. So I could have lined this up down here, and that probably would have made sense, and that's fine. Because there's nothing that we can, we basically would be multiplying x cubed by 0. Now we are able to erase this first term and focus on the next one that has a numerical coefficient that's not 0. So I have to figure out, what do I multiply x cubed by to get to 2x to the 4th? And that would be 2x. 2x times x cubed is going to be 2x to the 4th. 2x times 3 is 6x. I'm going to put the subtraction symbol. This cancels. I still have 3x cubed plus 0x squared. Now I'm saying 6x minus 6x, that cancels. I'm just going to keep these 0 terms there until I'm done. Make sure that that I take care of everything. I'm going to multiply x cubed by what to get 3x cubed? That is 3 plus 3. So I have 3 times x cubed, 3 times 3. Subtraction symbol. The first term cancels out. There's no x cubes. There's no x squareds. There's no x's. The 9's actually negative 9 minus 9 is negative 18. So I do end up having a remainder. It is negative 18 over x cubed plus 3. This is my answer. let's look at the next example. This time I am multiplying by a trinomial, dividing into the trinomial. I'm going to have to make sure I put these in order. So like 2x cubed goes first, 7x squared is going second, then my negative 4x, then 7. I'm not putting these in here out of order because that would be super, super confusing. Dealing with the very first term, I need to figure out what I multiply x squared by to get 2x cubed, and that would be 2x. 2x times x squared is 2x cubed. 2x times 2x is 4x squared. And then 2x times 1 is negative 2x. Set of parentheses, negative symbol. These cancel out. 7x squared minus 4x squared is 3x squared. Negative 4 minus negative 2, so this is actually a positive 2, is negative 2x. And then the 7 comes down. X squared goes into 3x squared 3 times, so I'm going to put plus 3. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times negative 1 is negative 3. Combine. What I have left down here is 4, oops, I'm sorry, I got to go ahead and put my negative out there. And if I didn't notice how much that affected my answer, negative 2x minus 6x is negative 8x. 7 minus negative 3 is 7 plus 3, which is 10. Now, this is the point where we have to say this is going to be our remainder because x squared doesn't go into 8x. It's bigger than that. So my answer is going to be 2x plus 3 minus 8x plus 10 over my original x squared plus 2x minus 1. Notice that this negative became that separating symbol, so important to know. Yeah, so all of our examples had remainders except for the very first one, so that's really interesting. I give you a homework to go with this, and there's 9 problems. You're supposed to pick 6 of the 9. I want you to do your best. I don't want you to freak out if you don't know how to do everything perfectly. You can send me questions. That is it, and I will see you next Friday.